Looking at Math 151, Section 4.1 notes on maxima and minima. First, we have the definition of absolute maxima and absolute minima. The definition of an absolute maximum is that the point f of c, which is the y value, has to be greater or equal to all other f of x values, so all other y values for every x in the domain. Then f of c, again that's that y value, is an absolute maximum. The same is true for the absolute minimum if it's instead smaller. So if f of c, again that's your y value, is less than or equal to every other y value in an interval, then it is an absolute minimum. We use the phrase absolute extremum if we are talking about, in general, a maximum or a minimum. So we use the extreme to classify both of them. So an absolute extreme is either an absolute max or an absolute min. Okay, so there's a couple of pictures here. The following graph show 4 different functions using the graph of y equals 4 minus x squared with different domains. Identify the domain in the absolute extreme. Okay, so it's the same function every time. I'm just restricting the domain. So in the first one, my graph is going down both sides, so the domain is all real numbers, negative infinity to infinity. Absolute extrema, there is only one absolute extrema, and there is an absolute max. And it's at 0, 4. So oftentimes we will give the ordered pair for the absolute maxes. We talk about the 0 as the location of the absolute max and the 4 as the absolute maximum value. So f of c right here is the absolute maximum value. We use the word value when we're talking about just the y-coordinate. The maximum itself could be an ordered pair. We talk about the x-coordinate as the location of the maximum. Okay. Now, if I restrict the domain and look instead on the interval from 0 to 2, these are x values since it's domain, then I actually have both an absolute max and an absolute min. So we have an absolute max and an absolute min because I stop the graph at both of those 2 points. So I have absolute extrema, I have an absolute max at the ordered pair 0, 4, and I have an absolute min at the ordered pair 2, 0. Again, the maximum value would be 4. The minimum value would be 0. Those are the y-coordinates. But we give the full ordered pair to give the location of the extrema as well as the value of the extrema. So in an ordered pair, x comma y, we have the location, and then we have the extreme value. All right. In order to know that something is an extreme value, I have to talk about the y-coordinate because I'm looking at the highest or lowest of the y-coordinate. So that's why we're talking about specifically the extreme value. This one is the maximum because it's the highest y-coordinate. This one is the minimum because it is the lowest y-coordinate. Okay, taking a look at the next couple of graphs, they change in domain because I have some open circles here. So the domain on the next one is going to be open circle 0, comma 2, closed bracket, open and closed. And so because the first value is open, that's not going to be an extrema because there's no value, one single y value that is greater than the rest. I don't get to include 4, 3.9, but 3.99 is greater. I can't get actually to there. The limit is 4, but f of 0 does not exist. So there is no absolute max. There is, however, an absolute min. And so our absolute extrema is that there is an absolute min at 2, 0 with value 0. And the last one, since I have a domain that is open from 0 to 2, I will have no absolute max because there's no highest y value there, And I will also have no absolute min. There's no lowest y value there. So there are none or no absolute extrema. On our next page, looking at the extreme value theorem. The extreme value theorem says that if we are on a closed interval, a to b, then the function is guaranteed to have both an absolute minimum and an absolute maximum. Okay, it's going to have both. That's only true for closed intervals. As you saw on the previous page, if your interval is open, you're not guaranteed to have one of the absolute extrema. But if it's a closed interval, you will have both. Only one of ours on the previous page was closed. Notice that all real numbers is an open interval. If I have a closed interval, I do have both an absolute max and an absolute min. But if I have any open, I may have one or I may have none. All right. And again, the note here, this theorem states that there are two conditions needed to ensure the existence of the absolute minimum and absolute maximum. I specifically talked about the closed interval. The other condition is that the function needs to be continuous. I read that first, but we needed to emphasize that again. The two conditions are continuous function and closed interval. All right. So in example 2, we're going to identify the location of some absolute extrema on the given domain and discuss whether or not these functions meet the conditions of the extreme value theorem. Okay, so the first one has an absolute min, but it is not going to have an absolute max. That's because the interval here is not closed or it's not continuous. The reason being not continuous. Okay, if I look at the next graph, this one does happen to have an absolute max. And it does happen to have an absolute min. These are just the highest and lowest y values. It achieves them. So I've identified the locations. Does the function satisfy the conditions of the extreme value theorem? No, it does not. It is not continuous. So the extreme value theorem, if both conditions are met, guarantees the existence of both an absolute max and an absolute min. They can both occur without it being met, but they can't be guaranteed they will occur without it being met. So even though this one does not meet the extreme value theorem, it happens to have both of them. I couldn't have guaranteed that it would. Okay. In the next one, this one does satisfy the extreme value theorem because it is continuous and it is a closed interval. So it should have both. And we can see that it does have an absolute maximum, and it does have an absolute, that's not it, it's right there. It does have an absolute minimum. Common mistake is to go for the endpoint. It's not the endpoints all the time. It happened to be in the previous one an endpoint. Here the absolute minimum is at an interior point. So very good to point out that we could have it happening at the end or at an interior point. We were guaranteed that they were going to exist by the extreme value theorem. In the last one, this interval is not closed. And since it's not closed, we are not going to be able to guarantee the existence of an absolute min or an absolute max. In this case, it doesn't have either. So that would be our candidate, but it's not contained, so there is no absolute max. And this would be our candidate for absolute min, but it's not contained, so not an absolute